All right, guys, welcome to today's class. Today, we're going to continue where we left off last week. All right, let's get started now. In the figure below, BOC is 42 degrees, O is the center of the circle, CD is parallel to OA, and BAO is equal to BCD. Now, we want to find CBO. Now, how do we approach that? Well, notice that we want to look at isosceles triangles, right? Or equilateral ones, because they tell us most about the angles, right? Here we have an isosceles triangle. BOC is one because radii are always equal. Same radii from the same circle are equal. So from here, we can say since BOC is 42 degrees, we know that OCB is equal to CBO, or is 180 minus 42 degrees divided by 2, which this comes out to be 69, I believe. Yeah, I'm pretty sure I'm right. 69, yeah. 69 degrees. Now show that BOA is equal to 180 minus 4 BC. 180 minus 4 of this BCD. And we know that BAO is 2 BCD. Well, first thing that comes up to mind is that using isosceles triangles yet again. We notice that since BCD, 2 BCD is equal to BAO, notice that OBA and BAO and OBA are base angles, and they're the same in this isosceles triangle. So it's going to be 4 BCD because 2 times 2 is 4. And then you subtract it from 180 to get the vertex angle. And this proves the statement. Alright. Now we want to find BOA. Alright. Now let's guys have a try on this question and tell me answer to chat. It might have to do with the relationships we used before. Alright. Let's guys try this question and tell me answer to chat. Let's get started with this question now. So to find BOA, we want to examine the isosceles triangles, right? Now, well, one thing we could try, is at least finding angles that we could find. Well, we notice that CD is parallel to OA. That might give us a hint. Let's clear things up. All right, so CD is parallel to OA. So what does that show? Well, we can draw this line. All right, there's this line. Extend these lines. All right, now this angle will be equal to this angle. And we know from before that BOC is 42 degrees. And we know these two angles are the same. All right. What else can we find? Well, that this angle is also, this angle is 180 minus 42. So we know this one's BOA. You can do 180 minus 44 BCD, all right? I already wrote that down. So we can say 180 minus 4 BCD plus 42 degrees is equal to a grand total of, I don't know how much degrees. You'll just say X degrees. Well, we want to also find this angle. Well, this is going to be 180 minus that, all right? So we want to have 180 minus this entire thing. And here is going to become what happens next, all right? So notice that, from here, OCD, that's the 180 minus part. That's going to be equal to OCB, which is CBO also, or 69 degrees, plus BC. All right. From here, you can solve. All right. That's just going to be 4 BCD minus 42 equals 69 plus BCD, same side. Put on the same side, that's going to be equal to 3 BCD is equal to 100. Am I doing this correctly? Hold up. 111. This is 37 is equal to BCD. 4 times 37 is equal to 148. 180 minus this gives you 32, and that's your final answer. Yep. So answer is 33 degrees. So we want to find two things that are equal to 1. We want to find two things that are the same, all right? Like, we want to compare two things. If we can't only have one x, we want to find that two things such that we can make an equation out of it, all right? That's the whole idea. Now let's move on to 3.34. AB and XY are diameters of O. Prove that AX is equal to BY. I'll also have for trying this question in terms of the chat. All right, guys, let's get started with this question now. We want to prove AB and XY are the same. All right, we already know that AB and XY are the same. Their diameters, right? We want to prove AX is equal to BY. Well, how are we going to prove this? Well, the first thing that pops up is that we can prove that their rectangles are parallelograms. Let's see, AB. Notice that AB and XY bisect each other. That's the first part. Alright? We know that AB and XR are bisecting each other because they all both intersect the center. But if they intersect the center each, and they're both radius, then these means that these are equal. Alright? And and additionally, these are vertical angles, so we can draw these lines, this line, by SAS. This shows that AX is equal to BY, and similarly, AY equals BX. Alright? Last one, 3.35. Triangle ABC, let M be the midpoint of BC. Prove that if MA equals MB is equal to MC, then BAC is equal to 90 degrees. I'll just over trying this question, then turn this to the chat. Let's try this question. All right. So this question will not. All right. So this one. In triangle ABC, M is the midpoint of BC. For that, if MA is equal to MB is equal to MC. Oops. Wrong diagram. Then BAC is 90 degrees. Well, this is not that hard to prove. Well, if MA equals MB is equal to MC, well, this is just telling you that these angles are equal. And since these two are equal, say that's x, 180 minus 2x. Well, this is 2x. What is this angle? Since it's an isosceles triangle, this is gonna be 180 mi 90 minus x. And this is also 90 minus x. Hold up. Oops. Let me see. 180 minus 2x is that. And then we subtract, we get 2x, right? Over here is 2x. And since it's isosceles, this is gonna be 2x, 180 minus that. This is 90 minus x, alright? I believe I have the wrong diagram here, but this is gonna be right. Alright, this shows that it has to be a 90-degree triangle. That's the whole point of this problem, is just to show that this must be a 90-degree triangle, alright? So this would be 90 degrees, alright? Not false, alright? Now let's move on to 3.36. All four angles of a square are 90 degrees, and all four sides have the same length. Square EFGH is inscribed in square ABCD as shown at right, meaning that each vertex of EFGH is on the side of ABCD. Show that AHE is equal to BEF, and prove that AEH, BFE, CGF, and DHG are congruent. Also, ever try this question and tell us in the chat. Let's get started with this question now. So, how could we approach this question? Well, notice that we have a bunch of squares, so we should make use of a bunch of equal sides, right? Well, so that each is equal to BEF. This is 90 degrees, this is 90 degrees, this is x, and this is 90 minus x, and the result follows, alright? Now, prove that AEH, BFE, CGF, and DHG are congruent. You can easily prove this by using one argument. We can only just prove two of them, and the result will follow for each of the rest. Right? Since A, how do we prove that AH is equal to BF? By ASA, this follows. Because of x, 90 minus x, x, 90 minus x, and this equal sign. And the result will follow. Alright? Now let's move on to 3.37. In the figure below, triangle DEF is equilateral. AE is equal to BF is equal to CD, and AD is equal to BE is equal to CF. ABC is completely inside DEF, and no two triangles no two of the triangles ADE is going to be ADE, BEF, and CFD share any points besides the vertices of DEF. Prove that ABC is equilateral. I'll just have a try this question and turn it to chat. All right, let's just start with this question. So to prove that ABC is equilateral, or how do we go on to approach this? Well, we know that AD is equal to BE is equal to CF. Or we gotta prove that the lengths are the same, right? We have AE is equal to BF, is equal to CD, and so on. So we have S and S. We got two sides. Now we just need an angle in between. Alright? So how do we go on about to approach it? Hmm. What can we do? Let's take a look at these angles right here. What can we do about them? We know that this entire angle is 60 degrees. Right? Entire angle is 60 degrees. If we said this is X, this is 60 minus X. Minus the Y. See, this is Y. Alright? Is there any way we can do it to find the angle? Let's see. Well, the first thing to think about is just to try to angle just about this. Alright? Or do SSS. Alright? So we want to prove that ADE. From here, we want to prove that ADE is congruent to BEF and is congruent to CFD. That's another way to do this. Well, that's seems quite easy because of equilateral triangles and the sides are the same. Alright? So this is an equilateral triangle. This happens. So BEF is equal to BFD is equal to AED. Now from here, you get that these two sides are equal. These angles are congruent. So it's easy to see that this angle is equal to that angle is equal to that angle, and then by SAS, this follows. And then you get AB is equal to BC is equal to CA. Would ABC still necessarily be equilateral if ABC were not fully inside DEF? I'll just give a try on this question and interpret through chat. Well, let's get started with this question now. All right. So how do we approach this? Well, will ABC still necessarily be ABC if it's not fully inside DEF? Interesting question. Now, what happens if all, if, what happens if it's not completely in? Well, we could have like this, and that wouldn't be equilateral. Which will, this just tells you that it's not going to be equilateral, so no. But if everything, like all three of ABC is outside of DEF, that could be a different question for a different day. But this is straight up no. Why? Because you can construct it. You can go on some random construction. I can construct these, and then you can construct all of this, and you can just realize that you can just construct it to the way that it won't be equal. It can be one outside and the other won't. All right. That's 1, 2, 3, 1, 3, 8. And A, B, C, D, E, F below, A, B is equal to F, A, B is equal to E, F, C, D is equal to D, and C, D, A is equal to A, D, E. Prove that A, B, C is equal to E, F, A. Through congruency, please. Alright? I'll just gonna have a try on this question and terms through chat. Alright, let's get started with this question. So you can talk about reflection, but what does that really help us with? We want to prove with congruency, what we learned in this chapter, alright? So we want to prove A, B, C is equal to E, F, A. Well, we can simply do this by congruency, alright? So how do we do this? We first tackle the one with the most detail, all right? ADE and ADC. This can be easily proved through SAS, all right? So we know these five and 1, 2, 3, 4, 5. These are the same. These like the same, and the result follows, all right? By SSS. All right, that's all you have to do. You don't need to do reflections. You just prove it just like this. All right. Now let's go to 3.29. Which of the following statements must be true? For each statement that must be true, prove that it must be true. For each statement that it may not be true, explain why it may not be true. All right. NO equals MN. Algebratron A and B. All right. Tell me to chat, please. Thank you. Let's get started with this question now. We want to prove that NO is equal to MN. Well, is that always true? Well, you only go two angles on the side, so We get ASA from this. And ASA just shows that Mn is equal to NO, right? And the result follows. Now we're going to prove NO is equal to OP. Well, that is not necessarily true. Even in the diagram, it's a counterexample, so it's a no. And P is parallel to NO. In the diagram, it is indeed also a counterexample, right? So it's no. And MO is perpendicular to MP. How is this true? How do we do this? Well, notice that M and O, and then we have MP bisects M and O and MPO, right? So it's gonna be like this diagram, alright? Now we're gonna prove that these are perpendicular. Why does this happen? Why is this true? And how do we prove this? Hmm. How do we prove that this is perpendicular? Well, from here, we know that MO, these triangles are congruent always. And from here, you can draw this line and notice that these are right angles because these are isosceles triangles, and the result follows. All right. Now, finally, we're going to move on to 3.40. In the diagram at right, A is the center of the circle, and CD is perpendicular to AB. We are given that ACD is equal to 2DCB. Let DCB is equal to X. Find an expression for ABC and BAC in terms of X. Well, we have a bunch of 90-degree angles over here, so we might as well just make use of this. How do we approach ABC? Well, notice that BAC is pretty obvious. It's just going to be, and we know that DCB is equal to X. This one's pretty obvious. It'd be 90 minus X for ABC. And then from here, we have ABC. This is a bit more interesting. We have a 90 minus X, and we don't know this angle. That's the problem. So this is Y, and this is 90 minus Y. Yeah, maybe not letting it to be Y is a very bad choice. It sure seems like it. Notice that ACD is looks like a very good thing we can do. What can we use it? Oh yeah, it says ACD is 2DCB. My bad. ACD is 2DCB, this is 2X, and then DAC is 90 minus BAC is just 90 minus 2X. Alright. Or you can say show that this is just 180 minus 6X. And ABC, you can use these equations and equate, and you can get the answer is 67.5 degrees. But it's just simply the same thing as we used in previous questions. It's just finding one equation, one way to express it, and another way to express it, and setting them equal to each other to find the final answer. Right? So we finished all the review problems, I believe. And that's it for today's class. I hope you guys have a wonderful weekend, and I'll see you next week. Bye.